All right, so welcome to the summary of the first module. Here we're going to go through what we've seen over this material and the workshop and assignment for this module.
Right.
So Jimmy, what have we seen?
Right. I hope you have been enjoying the journey with our Three Kingdoms heroes. The heroes have met. They have even sworn their brotherhood in the Peach Garden. And the rest of the stories mainly focuses on the problems that they have encountered in forming their armies as well as doing weapon production. So what have we learned?
So that's the story in the technical side of the course. Well, we've seen basically how to model in MiniZinc, a basic modeling approaches. And we've learned the basic concepts of modeling.
Yeah.
So we have decision variables and constraints, an objective and an output statement to see the result of our model.
Wow, the objective is optional, right? Because actually students, they also learn how to differentiate between a satisfaction and an optimization problem.
Yeah, so those are two classes of problems we'll see throughout the course, where we just want to find any solution to our problem or where we want to find a good solution to our problem. So what else have we learned?
I think, of course, after a student has started doing modeling, they have to be able to run the models as well. So we have taught them how to make use of the MiniZinc IDE to run the models, as well as running using the command prompt. But of course, we never show that, but it's very easy.
Yeah. So we'd expect that most students will run the IDE throughout the course.
Yeah. Okay. Among the other things that students learn in modeling, I think one thing that is particularly important is the concept of enumerated types that allow us to give names to data that would really help to make our models much more understandable.
Yeah, and one thing we've seen, another important concept is this separation between a model, which is basically a recipe for solving a class of problems, and an instance, which is a model together with the data, which is a problem we can actually solve.
And then the students also got to see a very important data structure, arrays, that allow us to make use of iteration such as for all and sum, as well as array comprehension to process such array data.
Yeah, and arrays are going to be essential for us to be able to model a problem which takes arbitrary different sizes of the actual data, so we can solve different size problems with the same model.
Right, because of that, that will allow us to build one model that is general enough to allow us to use it to solve several related problems.
Exactly, and we've looked at classes of problems. So we looked at linear models where all the constraints are linear. This is a particularly important class because there is a kind of solver, the mixed integer programming solvers, which are specialized to handle this class of problem. And we can handle very big problems of this class.
Yeah, and of course, MiniZinc allow us to model nonlinear constraints as well, such as the not equal relationship.
Absolutely, and we've also seen a generalization of the not equal, which is our first global constraint. This is the all different constraint, which allows us to say that all of these variables take different values. And we'll see many, many more global constraints throughout this course.
And also in the last chapter, we learned a very important modeling concept in which we are allowed to make use of variables as indices for arrays.
Yeah, that's true. That's one of the powerful modeling tricks that we'll use throughout the course.
Yeah. What kind of applications have we seen?
So we've seen production planning. That's a very classic optimization problem that goes on throughout the world everywhere, where we're trying to work out how to best make use of the resources we have to build some products or build some internal things at the most efficient way.
Oh yes, we could see that production planning also has many applications as well.
So we saw graph coloring. Now graph coloring may seem to be a kind of a toy problem that no one's really interested in, but in every compiler there's graph coloring to do register allocation. And graph coloring is a kind of simplified version of rostering.
Yeah, and of course it has applications in timetabling as well.
And timetabling and rostering, yeah.
And then we also saw a knapsack problem.
Yeah, so the knapsack problem is kind of the smallest discrete optimization problem which has all the nasty things. It's NP hard, so it's going to be hard to solve. And it's really this exact trade-off between the constraints fighting against the objective, which we'll see as a large part of what we do in discrete optimization.
We all want to be able to solve knapsack problem because we always have limited capacity, but we always want to maximize our profits.
And knapsack problems occur as a sub-problem of many real-world problems.
Yeah.
So we've now finished the course material. Now you need to go off and do the workshop and the assignment. So workshop 1 is about temperature control in a forge, and you'll use linear constraints and arrays. And mainly it's there to try to make you see beyond the procedural view. The first part of it, you'll think, I could easily write that in a procedural language. The next part, where you're actually writing in controller, you need to think declaratively. And so that's the aim of that workshop.
Right. Remember to read the specification and try the problems before watching the solution videos.
And then assignment 1 is also, it's going to be fairly simple. They'll get harder, don't worry. So you're going to solve some cryptorhythm problems. The very first one is just checking that you can actually submit through the Coursera infrastructure. And then you'll look at more complicated cryptorhythm problems, all based around the 7 Paces poem story.
Right. So this is the end of the summary.